Assalamu alaikum. You know, today मैं खाली सोच रहा था कि with JWST out there, James Webb Space Telescope, ये पूरी कहानी about the Big Bang फिर से मतलब एक तरीके से हाईलाइट हो रही है। तो मैंने सोचा एक थिंग कि मैं सिर्फ I'm just going to log everything. I mean, the thing is I have learned कि कहाँ से बिग बैंग की कहानी एक्चुअली शुरू हुई थी. As much as, I mean, the thing is I have read and as much as I can recollect, I just want to log it. Um, कहानी आई थिंक जहाँ तक मुझे याद पड़ रहा है शुरू होती है with Charles Messier. Yes, he was a Frenchman. He was a French comet hunter somewhere in the 1700s. Um, and the thing is, he was the one who actually was looking into the night sky looking for comets. And while he was searching for comets, he actually came across lots of nebulae like bodies in the sky. Now, the thing is, I think nebulae like bodies were not, I mean, it was not the first time he actually discovered them or anything like that. उससे पहले भी मतलब आपके बहुत सारी गैलेक्सीज लाइक एंड्रोमेडा और उसके अलावा भी दूसरी गैलेक्सीज जो हैं लोगों ने नेकेड आई और विद द हेल्प ऑफ स्मॉल टेलीस्कोप्स उन लोगों की नज़र में थी. Arab astronomers were also looking at them naked eye. Obviously, at that time telescopes अरब्स के टाइम पर रखते हैं आपके डिस्कवर नहीं हुई थी या इन्वेंट नहीं हुई थी रादर. लेकिन द थिंग इज रखते हैं कि उन लोगों ने उनको कैटलॉग किया हुआ था. नाउ प्रॉब्लम विथ मेसियर वाज कि ही वाज अ कॉमेट हंटर एंड कॉमेट हंटिंग इज़ अ वेरी it's a difficult task because how you actually discover comets और लुक फॉर दैम इज़ कि आप एक नाइट स्काई का एक हिस्से को चार्ट करते हैं. नाउ माइंड यू उसके दौर में चार्ल्स मेसियर के दौर में कैमराज नहीं थे. तो बेसिकली द थिंग इज़ कि ही एक्चुअली हैड टू ड्रॉ वट एवर ही वॉज सीइंग इन हिज टेलीस्कोप वन पोर्शन ऑफ द स्काई. नेक्स्ट नाइट he would go ahead and focus the same area again in his telescope around the same टाइम और फिर वो उसको दोबारा चार्ट करेगा. क्या कहते हैं आपके नाउ देन द थिंग इज कि ही इज़ गोइंग टू कंपेयर हिज his phonograph or sketch with the one from last night. And the thing is, and try to see कि अगर इनमें से कोई भी स्टार लाइक ऑब्जेक्ट जो है did it move from its place. Sometimes the thing is that and if it is moving, obviously, I mean, the thing is then that's a comet, because I mean, according to those days, it could have been a planet too. लेकिन the thing is कि जो planets बहुत दूर हैं, for instance, Pluto, Uranus, or Neptune, they are. I mean, the thing is they are really out there, but the thing is they have a distinct shape of a planet and they have distinct color. So the thing is there is no room for error कि अगर कोई नेपच्यून को देख रहा है या अगर कोई प्लूटो को देख रहा है. प्लूटो वेल मे बी प्लूटो तो वैसे भी क्या कहते हैं बहुत बाद में डिस्कवर हुआ है. लेकिन द थिंग इज़ के नेपच्यून एंड यूरेनस को अगर कोई देख रहा है तो द थिंग इज़ के देयर कलर would be a giveaway that okay, this is definitely not a comet. You are looking at something else. Comet का जो है क्या कहते हैं जो कि अगर when comet is way far away in the solar system, it would actually look to you like a star, shiny, bright object, just like a star. But and क्या कहते हैं आपके now sometimes what would happen is कि if it has started its movement and it has come closer to the sun, तो उसकी वजह से it will start having a small tiny tail because of the sunlight and the heat. क्या कहते हैं आपके its debris of ice and dust would start to melt, and that melt would actually start creating a tail because of the solar wind, because it is actually moving against the solar wind. So solar wind is actually going to sweep away whatever stuff is loosely bound to its core or to its body, and the thing is, and it will be going back like a tail. Now, the closer it will get to the sun, the tail will get bigger and bigger, and then the thing is कि you know you are looking at a comet. लेकिन मीज़र का मसला ये था कि he was looking at some nebular objects which he was not sure whether he was looking at a stationary object or whether he was looking at a comet. और इस तरह के बहुत सारे objects थे which were confusing him. So after observing them night after night, he realized that they were not moving. But he was irritated by them, that they were distracting him. So he started to catalog them, and he created a Meser catalog. And that's what it is called, Meser catalog. And amazingly enough, he actually documented more than 100, I think 150 or 100 close to 150 objects in his lifetime, and it's called Meser objects. Like Galaxy Andromeda is M1. इस तरह से Crab Nebula is I think M22, something like that. So actually, yeah. So now, fast forward to 1930s. Okay, I mean we are talking like almost 200 years or 170, 80 years later. 1924 actually, to be exact. माउंट विल्सन पे 200 इंच की टेलीस्कोप माउंट होती है कैलिफोर्निया, और वहाँ का जो चीफ एस्ट्रोनॉमर है दैट्स एडविन हबल. Edwin Hubble decided that he wanted to take a look at these Meser objects in his telescope. He already, thanks to Meser, he had done a meticulous job of cataloging all these nebular objects and with their right ascension and declination in the sky. So all you had to do was dial a telescope to those coordinates and you can start looking at them. And the thing is, I think when he started to look at these objects, most of them were galaxies, some of them were planetary nebulas like Crab Nebula. So the thing is, he started to realize something. क्योंकि अच्छा, here's a point to be noted. उन दिनों ये बड़ा मतलब आपकी एक बहस थी बेसिकली, और कॉमन कंसेंसस ये था अमंगस्ट द एस्ट्रोनॉमर्स कि ये मीसर ऑब्जेक्ट्स जो हैं, ये जो इन अदर वर्ड्स नेबुलर ऑब्जेक्ट्स, दे वर नथिंग मोर than objects in our galaxy Milky Way. That was the consensus. There were lots of astronomers like Shapiro. Shapiro was a big name. He was an astronomer, and the thing is that he had actually spend time um, taking a look at these nebular objects with great details, painstaking details. उनका स्ट्रक्चर, कुछ जो हैं सिगार शेप्ड हैं, कुछ डिस्क लाइक हैं, कुछ जो हैं वो ऑक्टोपस की तरह से या क्रैब की तरह से दे हैव आर्म्स. क्या कहते हैं, he actually, he cataloged those too. And the thing is, he tried to explain what these were. But the thing is, common consensus was still that these are objects within our galaxy. So at that time, when Hubble started to look at them, he came up with an amazing idea. He actually realized that, wait a minute, these nebular objects have this structure which is very similar to our own galaxy, Milky Way. It has a core, it has arms, it has the outer bands, और फिर उसने उनका फासला निकालना शुरू किया यूजिंग रेड शिफ्ट्स, डॉपलर शिफ्ट्स. उसकी भी एक अलग कहानी है, उसके ऊपर बाद में हम एक बनाएंगे, एक और ब्लॉग बनाऊंगा. लेकिन द थिंग इज कि दिस वाज अमेजिंग. तो ही ऑल ऑफ अ सडन केम अप विद द रियलाइजेशन कि दीज objects are not within our galaxy but outside our galaxy, and each one of these objects are galaxy in themselves. ये तो मतलब आपके एक रेवोल्यूशन एस्ट्रोनॉमी के अंदर आ गया, because this actually increased the size of our universe exponentially. क्या कहते हैं आपके, I mean there were like hundreds and thousands of these nebular objects, and if you define each one of them or most of them as galaxies, then the thing is, I mean, it's like, and each galaxy has its own set of billions of stars. I mean, the thing is, the immensity and the vastness of space all of a sudden not multiplied but exploded exponentially. So एक कोहराम बरपा हो गया. और यही नहीं, बल्कि एडविन हबल ने एक और चीज़ भी की. उसने जब इनकी फासले जब इनके नोट करना शुरू किए और इनकी स्पीड्स निकालना जब शुरू की, तो ही ऑल्सो टोल्ड द वर्ल्ड कि these things, each of these objects, and we are talking about thousands, in those days there were thousands, and obviously today we know they are in trillions, but at that time it was like in thousands. Thousands of these so-called nebular objects, not only they are galaxies in themselves like our own Milky Way, but they are also all receding away from us, all of them. And no matter which direction you look into, they are receding away from us. And the further out they are, the faster they are moving. This was a strange picture. This actually told everybody that the universe was not static. Universe was dynamic. This, I mean, the thing is कि इस एक चीज़ ने इवन आइंस्टाइन को अपनी जगह से हिला दिया, क्योंकि आइंस्टाइन in his 30s, 1930s, जनरल theory of relativity को कंप्लीट करके बैठा हुआ था. And the thing is कि he even came up with his own equation about the size of the universe using general theory of relativity. Now, मज़े की बात यह है कि आइंस्टाइन की थियरी के अंदर क्या कहते हैं, यूनिवर्स वाज एक्चुअली मूविंग, it was not static. And Einstein said, what kind of craziness is that? Because everybody at that time thought that यूनिवर्स को जितना बड़ा होना था वो हो चुकी है. यूनिवर्स अपनी जगह स्टैटिक है, उसका एक डेफिनेट साइज है. तो द थिंग इज कहते हैं कि ही एक्चुअली put a limiting factor called lambda in his equation so that he could put a break for the universe to stop moving. Something, I mean, the thing is, which Einstein called the biggest blunder of his life after Hubble actually, came up with his observation that universe was racing away from us. Everything in the universe is racing away from each other. And he even calculated the rate at which rate it was actually racing away. And it was called the Hubble constant, H naught. उसकी एक वैल्यू है, which is at that time Hubble ने उसको calculate किया था at 100 megaparsec per second, I think. I might be off. I can double check, but anyway, that's what he said. Anyway, with over time, क्या कहते हैं, that number, उस number की अपनी कहानी है, लेकिन the thing is I don't want to go into that in this discussion. तो the thing is देखते हैं कि Hubble टेलीस्कोप जो 1989 में स्पेस में गई थी, क्या कहते हैं आपके 89-90 में, उसने क्या कहते हैं हबल कांस्टेंट को जिस वक्त कैलकुलेट किया था, तो इट केम अप इन द नंबर ऑफ 70 मेगापार्सेक पर सेकंड, और पर सेकंड आई थिंक इट्स एक्सेलरेशन, इट इज़ लाइक एन एक्सेलरेशन. राइट नाउ जेम्स वेब जो टेलीस्कोप है, उसने क्या कहते हैं उसको दोबारा से जब देखते हैं आपके जब कैलकुलेट किया, तो इट केम अप विथ 67 माइल्स पर मेगा पार्सेक पर सेकंड. बाय द वे, एक पार्सेक जो है इट इज़ एक्चुअली इक्विवेलेंट टू 30,000 6,000 लाइट ईयर्स. आई थिंक 6,000 लाइट ईयर्स का एक पार्सेक होता है. तो द थिंग इज देखते हैं कि मेगा पार्सेक, दैट मीन्स कि 1,000 टाइम्स दैट. तो एनीवे, सो द थिंग इज देखते हैं कि आई जस्ट वांट टू नाउ, सो एट दैट टाइम when all of this was discovered, I mean, एक एस्ट्रोनॉमी की दुनिया में एक तहलका मच गया. इस चीज़ को मतलब आपके बहुत सारे एस्ट्रोनॉमर्स, खासतौर से एट दैट टाइम देयर वाज अ पर्सन बाय द नेम ऑफ फादर लेमेटायर. ही वाज अ क्लर्जी मैन, बट ही वाज आल्सो अ कॉस्मोलॉजिस्ट ऑफ हिज टाइम. ही वाज अ साइंटिस्ट टू. तो द थिंग इज कि ही एक्चुअली when he realized कि what Hubble was telling him, he started to contemplate. He said कि अगर इस वक्त हर ऑब्जेक्ट एक दूसरे से दूर भाग रहा है, तो दैट मीन्स कि अगर हम इस पिक्चर को अगर हम रिवर्स करें, तो हर चीज़ जो है वो एक दूसरे की तरफ खिंचना शुरू हो जाएगी, और उस वक्त तक खिंचती रहेगी जब तक कि वो एक पॉइंट पे जाकर कॉन्ट्रैक्ट हो जाए. तो द थिंग इज देखते हैं कि इफ एवरीथिंग कॉन्ट्रैक्टेड टू ए पॉइंट, दैट मीन्स कि देयर वाज अ बिगिनिंग टू द यूनिवर्स, कि वहाँ से उस पॉइंट से सब कुछ शुरू हुआ था. वो कुछ था जो फटा, और अभी जो है वो बॉम्ब की तरह से श्रैपनल्स जो हैं वो एक दूसरे से दूर भागते चले जा रहे हैं विद अ सर्टेन स्पीड और अ रेट. और इस फिनोमेनन को, फटने के फिनोमेनन को, दे कॉल्ड इट बिग बैंग. ओके, so that's how, I mean, the thing is, the Big Bang hypothesis came into business. Now, it was a hypothesis. Maybe it happened that way, maybe it did not happen that way. ये तो मतलब सिर्फ एक तखमीना था, एक ख्याल था, एक hypothesis था. लेकिन then Fast forward again from 1930s, come to 1964. Okay. Now, in the 50s, there was कुछ पेपर लिखे गए दुनिया में इधर उधर. एंड द थिंग इज आई थिंक कॉस्मोलॉजिस्ट ने ये कहना शुरू किया कि अगर एक बिग बैंग हुआ है तो उसकी एको यानी उसकी रेडिएशन अभी भी कायनात में मौजूद होनी चाहिए एंड इट शुड बी मेजरेबल. एंड द थिंग इज कि इट शुड एक्चुअली बी everywhere in the universe. It's like an echo. क्या कहते हैं आपके जब एक धमाका हुआ है तो द थिंग इज देखते हैं कि उस वक्त बहुत सारे मतलब आपके एनर्जी एंड रेडिएशन एंड ऑल ऑफ दैट यूनिवर्स वाज स्मॉल बट इट वाज फिल्ड विद दिस रेडिएशन. जैसे जैसे वक्त आगे बढ़ता गया यूनिवर्स बड़ी होती चली गई और ये रेडिएशन जो है वो डाइल्यूट होती चली गई. नाउ आई मीन द थिंग इज वी आर टॉकिंग अबाउट 1400 or 13.7 billion years. क्या कहते हैं आपके later this radiation would be at a very small scale but it would still be there and it should be measurable. उन्होंने कहा कि लेकिन इसको मेजर कैसे किया जाएगा. दैट्स नो जोक. 1964 AT&T Labs, Bell Labs, Princeton में दो इंजीनियर्स हैं. ओके, there are two engineers, Arnos and Arnos Penzias. Arnos and Penzias. And the thing is, hang on a second, guys. Okay, so Bell Labs के दो engineers हैं, Arnos Penzias and Robert Wilson. And the thing is that they are actually working on creating a microwave antenna. And the thing is that they are actually working out in the countryside, and the thing is that they put up this microwave antenna up and turn it on. While they are testing it, they realize that there is a constant hiss, there is a constant hissing coming into the which their antenna is catching. And the thing is, they couldn't figure out where is it coming from. At first, they thought that maybe it was static because of some bad resistors or capacitors. So the thing is, they went ahead and changed some of them, but it did not solve the problem. होते होते यहाँ तक बात आ गई कि अच्छा, then the thing is, I think they thought that maybe the hiss is coming from the city background. It's a city background में radio antennas हैं और भी पता नहीं क्या क्या चीज़ें हैं. So the thing is, I think maybe it's actually catching those runaway signals. So they actually pointed it away from the city out towards the wilderness. Lekin that hiss is still there. It's there. Then they thought maybe there were some pigeons who actually made nests inside their antenna horn. क्योंकि उनका जो antenna था, it was like a horn. It was a huge horn. So they actually went inside the horn and checked. वहाँ पे जाके उन्होंने ब्रूमिंग वगैरह करके थोड़ी सफाई भी की कि मे बी ये डस्ट वगैरह पड़ी है, हो सकता है उसकी वजह से क्या कहते हैं, बिकॉज इट वॉज अ वेरी sensitive antenna put up for a specific purpose. So the thing is, I think they found out that okay, there were, actually, when they went into the antenna to clean it, they actually found some pigeon nest and and some eggs. So they removed all of that, cleaned it out, and then the thing is, they said, this should be it. We should be okay now. And they went ahead, checked it out again, but that pesky hissing was still there. Hiss. And the thing is, and it was actually a microwave signal. It was a microwave radiation signal. So then they realized, no matter where they actually pointed the horn or the receiver, it was all around them. And after trying to isolate it from various techniques, they still could not get rid of that hiss. It was there. And they had no idea what that was. They just logged it, and the thing is that they could not figure it out कि ये कहाँ से आ रही है ये hiss. Now, मज़े की बात ये है कि after like maybe some months later, there was actually a symposium of electrical engineering. I think it's IEEE, Institute of Electrical Engineers and Electricians. क्या कहते हैं, उन लोगों का symposium हो रहा था वहाँ पे. तो Arnos and Wilson, they both presented their paper about their accomplishment of creating this this high gain antenna, which they created for Bell Labs. But the thing is, at the end of their paper, they also provided this discovery of them, theirs, कि भाई एक hiss है, it is coming from all over the sky. Seems like it's all around us, and we could not subtract it. We have no idea what the source is, but it's at the microwave spectrum of the wave band में ये आ रही है. Now, at the very back of that symposium, there was Robert Dicke. Robert Dicke was actually a Nobel laureate physicist at University of Princeton. And the thing is, and this IEEE symposium was also happening over there. So he just happened to sit in there, because Dicke was, he was a world-class physicist, but at the same time, he was also an experimentalist. And the thing is, and he wanted to keep up with what's going on in electrical engineering and electronics zone. So he was sitting in that symposium. As soon as he heard that, he started jumping in the back, raising his hand like this. And he said, I know what that is. I know what that is. That is the microwave background radiation. That is the echo of the Big Bang, which we have been proposing for last 20 years. And that was the first experimental proof of Big Bang. People from, पूरी दुनिया में हंगामा मचा. Everybody, all the astronomers started building their own antenna. Radio astronomers were at the forefront of it. And the thing is that they all started listening to the sky, and they all found the hiss. And the thing is, I think it was, I think it was like 1.8 megahertz or something like that. I will have to confirm that too. Lekin that was the first proof of Big Bang theory. By the way, here's a fact. We have all listened to the microwave background radiation caused by the Big Bang in our lifetimes. Remember TV पर जब जिस ज़माने में हम लोग के घर में टीवी होते थे ब्लैक एंड वाइट, क्या कहते हैं आपके, और इवन कलर टीवी पाकिस्तान में पीटीवी जब चलता था, और जिस वक्त पीटीवी की ब्रॉडकास्ट अभी शुरू नहीं हुई होती थी, तो you will actually, you turn on the TV and all you will see is white snow with that hissing sound, hiss, and the thing is, and you see the white snow all over the TV. And the thing is, it was very disappointing. कि okay यार अभी TV show नहीं हुआ है, and then the thing is, we'll turn it off. That is the microwave background radiation. That is the echo of the Big Bang from 13.4, 13.7 billion years ago. Even, I mean, the thing is, if you remember, I was not a big fan of listening to the radio growing up. It was always in the background somewhere. But I would myself, I never went ahead, जिसको कहते हैं उसके कान मोड़ना, फाइन ट्यूनिंग करना. पाकिस्तान में मैंने कभी नहीं किया. यहाँ पे किया FM वगैरह पर, लेकिन पाकिस्तान में कभी नहीं किया. हमेशा वहाँ पे बैकग्राउंड में सुनने को ही मिलता था, कोई ना कोई लगा के बैठा होता था. लेकिन whenever you would try to scan frequencies to find a station, in between stations you will hear a hiss. That is the same microwave background radiation of the Big Bang, the relic of Big Bang. बाद में, I mean, the thing is कि बहुत सारे मतलब आपके experiments हुए. In 1989, in 2000, Hubble 1989 या 90 में लॉन्च हुई थी. In 2000 there was another telescope, space telescope, by the name of Planck telescope. No, sorry, not Planck. Actually it was Planck telescope. It was called CMB, which stood for cold microwave background. Cold microwave background radiation को मतलब आपके कैच करने के लिए एक टेलीस्कोप लॉन्च की गई थी. एंड द थिंग इज के it had lots of instruments in it, and it actually captured all the signal of the microwave background radiation. And there was a paper which was actually submitted, and that was like जिसको कहते हैं ना आखिरी कील बिग बैंग थियरी के अंदर, which actually anchored it. Yes, Big Bang definitely happened. And the thing is that they actually came up with a map of the microwave background radiation. विश मेरे पास तस्वीर होती, वो भी है नहीं मेरे पास. मे बी बाद में कभी मैं पोस्ट करूँगा उसकी तस्वीर. And it is amazing. And the thing is that इस वक्त cosmologists learned a lot about the universe just by looking at that map. So that is the story behind Big Bang Theory. Okay, signing out. Bye.